Okay, so good evening, everyone. I hope you all are doing great today. It's a pleasure to welcome you all to this exciting session on why LLMs need memory. Today, we are gathered here to explore one of the most important challenges in modern AI, how large language models can move beyond simple responses and start remembering information like humans do. So, as AI systems become more powerful, the need for memory context and long-term reasoning becomes critical. And today's session will help us understand why memory is essential for building reliable AI agents. So, thank you for all taking time out of your busy schedule to join this event. Before we begin, let me briefly introduce myself. My name is Aditya Kumar. I am an AI ambassador at Lamatic, the CTO of English learners as well, and I also work as a data analyst. I have been actively involved in AI communities, developer events, and knowledge sharing initiatives. And it is always exciting to bring together people who are passionate about technology and innovation. Today, I have the privilege of hosting this session and learning together with you all. Before we move forward, let me also briefly introduce Lamatic.ai, what it is, how it works. Lamatic.ai is an agentic development platform that helps business and teams transform their domain expertise into intelligent AI agents. The platform enables organizations to build AI agents faster, automate repetitive workflows, deploy intelligent systems that can operate independently, scale AI solutions efficiently. With Lamatic, teams can focus on innovation and productivity, while AI agents handle operational tasks. So, this event is brought to you by the Lamatic Investor community. And let me quickly walk you through our today's agenda. So, first, we'll be having understanding the problem why LLMs need memory, how techniques and adding memory AI system works, real world implementation and platform deep dive, and one surprise for you all, that is quiz at the end. So now it's my honor to introduce our amazing speaker for today. We are joined by Arun Addagatla, who is founding engineer at Lamatic.ai. Arun is deeply involved in the field of generative AI, agentic AI, and MLOps. He's he is specialized in building robust AI pipelines and intelligent agents that business rely on every day. With this experience in designing a scalable AI system, Arun has been working at the forefront of bridging the gap between cutting edge AI capabilities and real world reliability. Today, he'll be share his insights on how AI agents can equipped with long-term memory, how to ensure explainability and transparency in AI decisions, how platforms like Lematic.ai accelerates the development of intelligent agents. I'm sure this session will be extremely valuable for everyone interested in AI, machine learning, and intelligent systems. With that, I would like to warmly welcome Arun Adagatla to take over the session and share his insights with us. Arun, the stage is yours. Thank you.
Yeah, thank you for the intro, Aditya. Thank you for the warm introduction and welcome everyone. Since Aditya already had an intro of what we are going to learn today, so I'll just give a short intro. So today, our primary focus is to understand why do LLMs needs memory and why only LLMs are not capable of doing the agentic development. So today's agenda is how LLM thinks. We're going to learn what memory means in terms of LLMs. We're also going to learn the architecture of LLMs, and we are going to have a hands-on live demo on how to implement this memory with LLMs in Lamatic. So before moving forward, a short intro about me. So hi, I'm Arun Addagatla. I work as a founding engineer at Lamatic, and I am a computer science graduate. I have a special expertise in GenAI and LLM, and I have been working in this field from past 4.5 years, I would say. And apart from this, I'm also a technical blogger. I write articles on Medium, share my insights with the world. So yeah. So let's not waste any time and jump directly into the today's session. So yeah. Uh, since I'm assuming many of you are already familiar with the term LLMs, so I will not like deep dive into LLM. I'll just give a short intro. So for those who don't know LLMs, I would say LLMs are nothing but large language models that are trained on a large set of data. And by training, I mean these LLMs are trained to understand the patterns in those data, like patterns about the vocabulary, the grammar, like nouns, verbs, all this grammar patterns is the one the LLMs try to understand. So yeah. So now let's so right now so since we understood how the LLMs works, so the main functionality of LLM works is LLMs predict the next token based on the existing data which has been fed to it. Like for example, if I ask it like, okay, quick brown fox. Now to predict the word fox, LLM uses the previous data which it had, like the brown, to identify the next one. So that's how basically LLM runs. So in LLM, there's a common term called context window. So what is a context window? So context window is nothing but the amount of information that is being provided to the LLM. And each and every LLM has a fixed set of context window, a limit on context window. Like for example, if you look at the popular LLM models like Llama, so Llama has like 128K context window. So yeah. So now so whatever you want to predict, whatever you want the LLM to do, the task or the prediction, you give it as the context to the LLM. Now there is a problem with this context. So each and every context has a limitations. Like you can't give n number of context to the LLMs. Like as I mentioned, few models has 128K. Even if you go with the smaller models, they have even more smaller context window. So if you want LLMs to remember your context, like for example, if I've asked LLM, okay, I am Arun, I want to learn Python, or I work at Lamatic, and now when I'm making in one more call to the LLM, it will not remember this answer. So basically, LLMs are stateless in nature. Like each and every API call which I make to LLM are completely independent. My first call context is not transferred to the second call, even though I'm calling to the same model using the same address and everything. So, so LLMs use context window for processing. They are stateless in nature. And obviously, if you stuff everything to the LLM in the one request, it slows down. Because let's say if you have a two paragraph of content, for example, I have a two paragraph content about myself, my LinkedIn profile or my resume. And if I want to know about my work experience, my education or my skill set is not required here. I only need the experience. So if you understand the pattern here, for the LLMs to answer correctly, we don't need everything. We only need the specific information. If we stuff everything, there is a chances of LLMs, getting like, misleading or giving an inconsistent answer. So that's why. So a bit expansion of what I was saying. So if you give big context to LLMs, the main issue is it hits the limit. And obviously there is a wastage of tokens because you don't need all the information. If you're asking for my work experience, you only need my work experience. You don't need my education, my skills, or anything else. So that's why you can't feed everything to LLMs. So right now we need a smart method. We need LLMs to memorize my conversations. So that's where memories comes in. So there are two types of memories which we want the LLMs to remember. We want it to remember short-term memories, and we also want it to remember the long-term memories. For example, if I have a personalized chatbot created for me, I want it to remember every information about me, and also I want it to remember the shortest conversation, the latest conversation which I had it with the bot. For example, if I had I know Python, now I want to learn JavaScript. And if you look at the long-term memory, in my long-term memory, only my Python knowledge is saved. And in the short-term memory, I want it to remember, okay, I know JavaScript or I know Java. So that's why we need LLMs to maintain both short-term and long-term memories. And yeah, so why do we need to like store memory? As mentioned, like first of all, the main reason is personalization. If I want the LLMs to understand my persona, understand my personal information, I want that LLM to have access to my memory so that whenever I ask any personalized question about my writing style or about my views, formatting rules, it can easily access that memory and it can get that data out of the system. And the second important purpose of storing the memory is continuity. So, for example, if I'm having a chatbot, if I'm having a conversation with an AI, for example, I'm asking, consider a customer support chatbot. So, I'm having an example. I'm asking it, okay, I have an issue with, for example, I'm not able to log in into the application. Now there is a ticket being raised for this query, and after 2 days, I have came back to the system again. Now, now as a user, I won't ask, I expect the system to know my previous issue. I will not again like describe my issue from the scratch. So that's the issue of continuity. For to continuity, we need memories attached to the elements, and obviously the better to get the better personalized answers. So these are the three major reasons why we need to like store memory and have LLM access to this memory. So there are two major ways to save memory, and obviously to save those two different types of memory. The first one is the short-term memory. So for short-term memory, we can use something called as episodic memory, or also known as sliding window. So in this technique, what we do is whatever conversation which we're having to LLM, let's say I've opened a chatbot, I'm having, let's say, 3 to 4 conversations. I will I will fix a sliding window. So in this, what do you mean by sliding window is the number of conversations I should keep with the bot. For example, if I have 10 conversations, I will only use top five, latest five conversations and give it to the LLM as a memory. So this is called as episodic or, sliding window memory, a short-term memory. Similarly, now to remember the long-term memory. So as mentioned earlier, we can't feed the whole, let's say 20, 30 conversations to the LLM in the single context. So we need a way to store that long-term memory. So for storing a long-term memory, we use something called a semantic memory. So to store a semantic memory, we'll be using a technique of semantic search. So for those who don't know semantic search, it is so so usually we are familiar with the full text search, or we are familiar with keyword search, right? Exact keyword search. Like for example, if I have a data called Arun is a founding engineer, and in keyword search, if I type Arun, it will give the exact match for the Arun. But in semantic search, it goes for the semantic meaning of the data. For example, king and queen, both of them, or maybe like a boy or a man. If you see, both of these words are not actual exact words, but they have semantically similar meaning. So that's how like semantic memory works. So there are like so as covered. So to store the episodic memory, we are going to use conversational buffer. To store the first type of memory, which is episodic memory, we are going to like store conversational buffers. So for this, we are going to keep the last n messages of the conversations. Like if I have a 10 conversations with the AI bot, I'm going to keep top five. And every time I'm going to make a request, I'm going to slide the window to the next latest conversations. And in every request, I'll be sending last five messages. So this n number can be optimal. It can be decided based on the use case which you're implementing. So there is no fixed universal number of, okay, how many conversations or what's the ideal count of conversations you should send to an LLM in a request. And second is the vector store memory. So similar to what we do in a vector search, and it uses somewhat similar technique of RAG. So RAG, for those who don't know, it's called retrieval augmented generation, which uses the vector search to extract the relevant documents and feed that relevant documents to the LLM to generate the final response. And the third type of design pattern is like using profiles, or we could say so in this technique, what happens is we create individual user profiles. Like for example, if you consider the chatbot example itself, if I have 10 different users who who might have be facing a 10 different scenarios or 10 different use case. Like someone might having be a logging issue, or someone might have a issue with, let's say, product not delivered or something. So each and every user should have a different profile created, and each user profile will have different persona attached to it. There'll be details like username, or like customer ID, all this information, or what are the previous orders, or what are their previous cancelled orders, all this information. So we'll create a different profiles, and each and every profile will be fed to the model real time based on the user query. I'll be showing this in the demo on how we are going to like how we can do a different profile based memory allocation to the model. So yeah, so this is so let's walk through a bit on the architecture of the how LLM and the memory can be tied together. So the architecture is pretty simple. So whenever a user query is hit to the LLM, right? LLM is going to call memory, or we can directly call the memory to get the relevant documents of that particular message. Like for example, if I have asked, like I have a conversation with the bot, I told it, okay, I am Arun, I want to learn Python, and after that I had like a couple of conversations, and I closed that session. Now, whenever I'm making a next call to the LLM, restarting the session, I want to extract that particular information about my previous conversations. So for that, we are going to embed my initial input requests. Like for example, whatever my text is, we are going to transform it into the vector representation, and we are going to do a retrieval, that is the vector search, from whatever vector DB we have created using similarity techniques. There are different techniques which we can use. For example, you can use similarity techniques to extract whatever the similar information is there for that particular query. And then we are going to combine all those things and feed it back to the LLM with whatever previous memory which we have and the new latest query. And with this information, LLM can now easily answer the personalized and create a personalized response for you. So you can think of it as like LLM as a brain, memory as a memory store as a notebook, and the retrieval technique as the flipping pages. So this is like, so if you look overall, it's like a pretty simple architecture. You get the user input, you get into embeddings, you extract the relevant information. Once you got the relevant information, You give it to the LLMs and you generate the final output out of this. So this architecture is almost similar to RAG, but the only difference is whenever we get an extracted information generated from LLM, we want to dump it back into the memory. So this is the only crucial change, or the difference between RAG and memory. So yeah. So how we are going to implement this in Lamatic? So in Lamatic, to implement the whole memory architecture, we have three different components. So the first component is memory store. We could also call it as a vector store, where we are going to store our memories, like the user IDs, along with the metadata, like user IDs, session IDs, or some other information which we want to store. And the second is obviously we need two nodes, one node to add the data and one system to retrieve the data. So in LLMs, we have this, in Lamatic, we have this concept called as nodes. So for each and every operation of adding a data to the memory, we have a memory node. For retrieving the data from the memory, we have a retrieval node. So yeah, so we can have a small, quick hands-on demo on how to implement this memory in Lamatic. So let me just quickly share my screen. Yeah, jumping into the implementation, a short intro about our platform. So in Lamatic, once you sign up into Lamatic, so in Lamatic, we have this thing called as projects, where we have flows, data, and different components. So for whatever system logic which you want to implement in Lamatic, you can use flows. So what is a flow? So if I open a particular flow, a flow, yeah. So if I open a flow is nothing but a combination of nodes. You use different nodes to solve your business logic. Like, and in Lamatic, we have something called as trigger nodes. So there are different trigger nodes with which you can trigger this particular flow. So like for example, there's search trigger, chat trigger, ask. You can use API webhooks as well. If you want to pull data from different apps, you can use those things as well. So for this demo, I'm going to like use a chat trigger. And in so once you added a trigger, you can configure the trigger as well. You can set the allowed domains and everything. And you can even configure your chatbot. So I'm not diving deeper into each and every configurations, but yeah. So once you have a chat trigger, now you can add different nodes as well. Like there's an MCP node, text generate, image, multimodal, RAG, supervisor, everything. And if you look at memory, go into the data section, you are having memory add node and memory retrieve node. So first of all, I'm going to show an example of a session where I'm like conversing with a chatbot, but without memory, and what's the benefit of using memory. So we can start. So yeah. So once you, let's say, added a text generate node, right? So in Lamatic, you can configure which model you want to pick. So let's say if I've already added credential for this model, but yeah, you can pick your own model by clicking on add provider, and you can use any model. We have over 100 plus models added into Lamatic. You can choose a provider, you can add those API keys, those credentials, and once you click and save, your credentials will be shown here. And based on the provider, obviously the models will be shortlisted. So for now, we are like just picking the GPT-4 Omni, and you can also configure system prompts. So I've already wrote a system prompt here. So in this prompt section, you can easily like configure system prompt. You can change whether it's a system prompt, user prompt, or assistant prompts. And you can also pass the chat history as well. So in this in Lamatic, we have this thing called as variable selectors, where you can use the output from the previous nodes as well. So if I go in messages, I want the chat history from the previous trigger, right? So I can just select it. I can just create and it will be placed over here. And you can also attach memories directly to the chat trigger node itself. So this is how chat you can configure a LLM node in Lamatic. And now if I want to like configure the chat response node, so now in chat response node, there's this thing called as content, which nothing but returns the output exactly of the chatbot. So here I want the response that's being generated by the AI node. So I'll be like selecting that. Uh, yeah. So now once my whole data is configured, I can just click on debug and I can have a conversation with the bot. Like for example, if I ask it, hi. So if you see, this is the executor workflow debugger, where you can see the input and output of each and every node, what happened in the each and every node. In the output node, the output of this text generate, what were the cost, everything. You get all the information here. Now, if I say it, I am Arun, and I want to learn Python. So if I had the conversation with this, so now I had a back and forth conversation with this model. And now if I ask it a question, how to implement loop. So now if you see, this chatbot is able, I haven't mentioned how I, like in which language I want to implement loop. It got the context from the previous message, which is a short-term memory, and answered and generated the code in Python itself. So this is how a short-term memory works. But since I haven't attached any long-term memory, if let's say I've closed the session and I have came back and now I'm asking it the implement for loop. So the chances are in one iteration, either it can generate it in Python or it can also generate it in some other language like C, C++, or anything. So now let me show you an example of, oh yeah, obviously you can save the flow as well. And now let me show you an example of how to use a long-term memory and make sure the conversation context is preserved. For example, so this is a pre-existing flow which I've already created. So I've added a chat trigger and I have added a memory retrieval node. So here you can set your search query and you can choose your vector store. So if you look at the presentation, there is one component called as memory store. So in Lamatic, you can just either pick your existing memory store or you can just create a simple memory store. So I would just say it as docs and just click on create. So this will just simply create your memory store. This is you can see that memory store. Same, you can add the model provider. You can choose the embedding models, and you can also choose the limits, and you can also apply something called as filters on how do you want to like filter the data. So yeah, and then so if you look at the architecture, the first component itself is doing the search and extracting the relevant information, which is done by memory retrieval node. And next is I'm now giving this retrieved information to the LLMs. So if you have seen, to configure the text generate node, same system prompt, user message, model configuration, and I can also pass chat history, and now I can also pass memories to it. So I can pass the retrieved from the previous node, same using the variable selector itself. Memory, I can just use memories, it will be passed to this node. And now once this answered, once the chatbot answers this, now I want to update my memory. I want to add this latest information into the memory. So for that, I'm going to use memory add node. So same, you need to you can specify the unique ID, and you can get this unique ID. Like this can be anything. So if you remember in the conversation, we had one more thing called as profiles, how to create different user profiles. So that you can create in Lamatic using this unique user ID. So with this, you can easily separate your memory between different user profiles. And I can choose the memory store. I can add different messages. Like I want my memory to store the generated AI response. I want it to store my user message as well. And yeah, same. I need to like choose the embedding models. I'm picking ADA itself. I'm using this credential, and I also need to like choose which model I want to use. So I can use. I'm picking for now GPT-5 Nano. We can use even a smaller or a faster model depending on to your use case. And I'm also preserving the session ID into it. So now let's just test this. So now if I ask it, hi, I'm Arun. I want to learn Python. So if you see, the model has generated a response for this, and obviously there is no data in the retrieval, so that's why it's showing empty memories. Once the generation is done, now it's getting added to the memory. And if you see, there's different personas that have been extracted from this response. So this is what the response is generated. Now to add memory, we are creating different memory actions. Like I want to store the user name as Arun, and the user intent is he wants to learn Python. Now, if I just reset the session and if I ask implement for loop. So now if you see, it has extracted my previous memories, whatever conversion memory I have, it gave it to the LLM. And now, if you look at the LLM response, it already greeted me, okay, Python is a fantastic language, and it wants to like understand exactly what I want to like implement the loop in. And once this response is again then dumped into the same memory node, and I can keep having a conversation with the memory. So this way I'm preserving the long-term memory. And if I'm staying in the same session, I'm also preserving the short-term memory as well. So this is how you can implement it easily in Lamatic. And once you're done, you can just click on save, and the whole workflow will be saved. And once you save a workflow in Lamatic, you can click on deploy to deploy this workflow. For example, can select which flows I want to deploy, and I can select implemented chatbot, for example. I can just click on deploy. So this hardly like take 10 seconds to deploy. So in the meanwhile, and yeah, if you go to the data section, you can also explore the vector DBs or the memory store that's being created right now. So you just have to go to data stores where there are context stores. And here, if you see the docs data has been created, docs memories. And if you click on it, you can see each and every memory that's being created inside your vector DB. So it also shows what's the memory created, what's the timestamp. Since I haven't added any metadata, so there's no metadata, but you can like, it shows the vectors that has been created, everything. So yeah, you have created a chatbot. Now, how can you implement this chatbot and show it to the end user? So for that, you can easily set up this chatbot or integrate this chatbot into your existing website. So let me show you with this flow. So whatever flow you have created in Lamatic, there is an option of to set up this particular flow. So you can use a simple like vibe coding prompt. You can just click with open with lovable v0 or pod.new. It will automatically create it. Or if you just want to like for this demo purpose, I'll just showing it in W3 schools. So we just click W3 schools, and I'm copying this API section from here, the scripts. And if I go to W3 schools, and let me just click on try it yourself. And let me just paste this inside it. Still a bit time to load. Yeah, so the chatbot has been shown up, and I can like have a conversation with it. Right? Yeah, so you got a response from this. And in Lamatic, you can also look at the conversations or the API calls that made to your project. So there is a section called as logs. So once you click in this log section, you can see whatever conversations you had previously. I did some tests, so that's why there's this 500 failed before the call. But yeah, so you can click each and every log, and you can get a complete log trace on what happened in each and every node, what was the output generated, everything. So yeah, so it's the quick demo. We just yeah. So as you saw in our demo, we saw how to like set up the store, how to build a particular flow in Lamatic, how to execute and test this flow inside Lamatic itself. So now let's talk about the common issues or common like pitfalls that happens when people implement memories. So there are three major issues in implementing Lamatic, or the way with which people implement wrong memories. So the first is noisy retrieval. So so the retrieval can highly like depend on the model and the quality of answers which you're storing. We don't want, so the demo which you have stored, it's a very basic demo, but when you go to the production use case, you don't want to store each and every information or each and every conversation, because the end user can sometimes have a recurring or a garbage collection conversation which you don't want to store inside your data. Like for example, user is saying ki, like you're having a conversation with the bot, he's saying what's the status of my order, and there's a response from the chatbot, and user is asking, okay, how long does it take? So you don't want to store all this information. You only want to store the necessary user information. So that's why if you keep storing each and every conversation into the memory, it creates a noisy data inside. And if you have a noisy data, there's a chances are whatever answers or the whatever the persona you're trying to store of the end user will not be like saved correctly. So that's why noisy retrieval is one of the biggest issue which everyone needs to take care whenever they are storing memories. And the second thing is data stillness. So, so in that demo, I've showed how we can avoid data stillness. But usually, what happens is people they don't keep updating their memory. What they do is once they pre-create a user profile. Like for example, when user came to my website, he created his profile. So usually, what people do is they just store all this information into memory and they don't update this memory over time. So as a user, if my persona changed, for example, I have let's say earlier I used to like, for example, like noodles. Now I don't like noodles, or maybe I like some other thing. So this data needs to be updated. So you can't keep your memory as stainless. You need to like keep updating that memory. So in the demo, as we saw, we have added a node called as memory add node. So that memory add node itself in Lamatic also handles the updating of the memory. So you don't need to like perform any other operation externally to update the memory in Lamatic. So that's the second issue where people don't keep their memory up to date with the latest information. So you need to make sure that you are updating your memory. Uh, yeah. And the third issue is like obviously the privacy and safety. So uh, so you can't like obviously store the sensitive information inside memory, like because there are different protocols that are implemented to avoid user data. Like for example, you can't store user passwords, or you can't store user phone numbers, or maybe other sensitive, like maybe their customer IDs, or if you're creating a system for specifically Indian users and you want to store the user data, you should not store their Aadhaar IDs, voter IDs, all this information inside your memories. Memories are only should only be used to store user persona or the user behavioral data, not the user sensitive data. So these are the three major issues that people and the most common issues that people do or like face while implementing memories. So yeah, now since we learned how to implement memory, what it is, how you can build it, what are the common mistakes. Now, let's learn how where you can build this, or what can you do with this memories once you have a memory attached to LLMs. So the common use case for the students who are like researching, or they are particularly in undergrad or graduations, they can build study assistant for them. Like for example, you can attach a memory store with your LLM where you're storing all your syllabus, curriculums, or maybe your uh, semester data and everything. And you can have a conversation with that assistant to get your curriculum details. You don't need to like go and search it manually. So you can have a study assistant created for you. And similarly, you can also have, if you're a working professional looking for a job or currently working, you can have a career assistant created for you where you can give it to your CV. You can give a CV attached to it, maybe your LinkedIn summaries, interview preparations, and everything. And now you can use this memory and LLM to maybe create answers for your job applications. And those job application answers will be completely personalized, and you don't need to like write those answers from scratch. So you can use it for that as well. And for companies, they can use it to create knowledge bots, that is user specific bots, where it's like these bots can be like used to do the meeting outcomes, or maybe analyze the conversations in a meetings or a one-to-one conversation with the end user. So these are like the common use cases with which you can implement memories along with LLMs. So yeah, so that comes to the end of this session. So there are three key takeaways from this session which we can consider. So the first thing is LLMs are stateless. You can't just use LLMs to build a reliable systems, because once you make a call, and whenever you make a second call, the information of the previous call is gone. LLMs don't preserve that. So LLMs are stateless at core. You need an explicit memory layer to make sure the conversation is preserved. The second is obviously don't just use LLMs to build the system. You need to build an hybrid system, a combination of memories and LLMs. And you can't just use only one type of memory. You have to preserve both short-term and long-term memory, the episodic memory and the semantic memory. So this way you are building a very optimal system. And obviously, So this in Lamatic, as you saw, so the demo which we have saw is a basic, it's a pretty basic and simple demo. But obviously, you can iterate and improve the, like you can do rapid prototyping and improve and make it feasible for the production development. So yeah, so we can have a Q&A session.
Yeah, okay. Thank you so much, Arun, for that insightful session. Your explanation about AI memory system, agentic architecture, and real-world application was extremely valuable and gave us deeper understanding of how modern AI systems are evolving. So we are truly appreciate you taking the time to share your expertise with us today. Now it's time for question. We are opening the session for question. Let's see how many questions we are having here. Yeah. How is that like user ID set in Lamatic to maintain user specific memory?
Uh, yeah, so I can share my screen to show it to you. So in memory in Lamatic, if you let me just reshare my screen just a second. Oh, I think my screen is already being shared. Yeah. If you see in the memory node, you can store the session ID, and you can also have a unique ID. So this unique ID, it can be like depending on use case, you can have a user ID, and if you don't want to save session ID separately, you can save it here itself. It's the in the unique ID. So whatever ID you store, that will be attached to that particular user persona. So let's say you have 5 different users, you can have 5 different user IDs saved in this. And if you see, this is being fetched dynamically, so you're not fetching or pre-configuring it in the flow. So whenever you're making or configuring your chatbot, you can configure the user ID by passing it in the setup itself. So yeah, that's how basically you make sure that the personas are different and there is a unique ID attached to each and every memory.
Yeah, cool. So one more question we are having. Where can I save sensitive user data in case that bot wants to access it, like order IDs or order related info?
Understood. So yeah, to usually you don't store this in memory, but you need to like use the actual database, the real data, or like SQL database or Postgres database to get this information. So we have this concept called as MCPs, where we can connect LLMs to the different apps to retrieve that data. So in Lamatic, we do have MCP's servers itself. So there's a complete like MCP itself is a completely different concept. But yeah, in short, it's nothing but it gives you LLM access to any data sources or any app you want, and LLM can retrieve the data and perform action in the particular app. So to save, or since you anyways be having those sensitive informations in your Postgres or SQL databases, you can attach it as an MCP server to the LLMs, and LLMs can fetch that information for you.
Pretty cool. Okay, one more question we are having, if we can take it.
Mhm.
Like, what does Lematic use internally for memory? It is graph based or vector based?
It is vector based. So in Lamatic, we use like vector-based memory storage and retrieval. So if you look in, if you go inside the
Oh,
data itself, so and if you open any memory store that you have created, you can see that there are like vectors assigned to each and every memory. Yeah. So if you see, these are actual vectors. So yeah.
yep, that's cool. So once again, thank you everyone for joining this session on why alchemists need memory. A special thanks to Arun Addagatla for sharing his valuable knowledge with us, and thank you to the Lematic investor community as well for supporting this initiative and helping build a strong global AI ecosystem. We hope this session inspired you to explore more about AI agents, memory systems, and future of the intelligence automation. Have a wonderful evening, everyone. See you there in the next event. Thank you.
Yeah. Thank you everyone for joining.